Hello everyone to like my 4th video about some Game Jam. This time is the 6th GMTK Game Jam, which apparently was so big that so many people tried to upload their games at the same time that itch.io crashed at the last minutes before deadline. Yeah, there were basically 6200 entries, making it the largest jam of itch.io's history. Anyways, this year's theme was Roll of the Dice, which was interesting. I spent some time thinking of game ideas, and I had roughly 6 of them by the first hour. Mostly 2 of them were pretty interesting and somewhat original though. The first one that I chose initially was a puzzle game, where the world has 6 sides and there would be wormholes arranged the same way as the dots on a dice. The wormholes could be used to travel between the other sides of the world, enabling some cool puzzles to be created. And yes, that sounds really overcomplicated and did not sound like a 2-day project. So I scrapped that idea after working on it for about 3 hours and went to bed. On the first full day tomorrow, I changed my game idea after realizing the problems with the last one. My new idea was a bullet hell / tower defense game where you defend the big dice from the enemies by throwing dice at them with different abilities, such as freezing enemies, poisoning them, piercing them, or just simply exploding them. Instead of going through the process of how I made this thing, I'll explain how certain things work in the game while showing you some code, so maybe you can learn a thing or two while watching this video. I have 2 cameras in the scene, one renders the game and the other renders the UI, and the first camera's pixelated render texture output. When throwing the dice, you need to convert the mouse position into world space coordinates. We can easily do this with this nice looking function. However, there's an interesting thing about how Unity cameras work. When assigning a target texture to a camera, the resolution in which the camera renders gets changed to the render texture's dimensions. This has some interesting side effects, such as changing the result of the screen to world point function, since it calculates the result using the camera's dimensions, not your screen's. To avoid this issue, I use the UI rendering camera, which is rendering at the screen's resolution instead of a way smaller one. Now that we got the world position of the cursor, we can instantiate the dice. When spawned, it plays a long spinning animation. The way I made it look 3D while the game is in 2D was to just rotate 6 sprites and offset them to create a cube. So now if I rotate the dice, it works just like a 3-dimensional cube would in a 2D game. The dice starts being big and decreases in scale to create this throwing effect. I also gave it a tiny bit of fade-in effect so the dice doesn't take up as much of the screen and to make it look better. There are 3 ways a dice can deal damage. The most boring one is by spawning another object that handles the damage, and this one is used by the black hole dice and the flame dice. The second one uses a circle cast to find nearby enemies to deal damage and apply debuffs to. This method is used for the dark explosion and the smash dice only, and makes these dice really great at clearing projectiles. The third and most complicated method involves a function that checks for particle collisions of a particle system. I'm not exactly sure how this works, but what I know is that shrapnel, frost, and poison dice use this method to deal damage to enemies. These dice are the best for dealing with large groups of enemies. Some attacks inflict debuffs. For example, the frost dice freezes enemies in place for a couple of seconds, the poison dice deals damage over time, and the smash dice knocks back enemies, but it usually one-shots them, so it's quite rare to see that. Each dice has its own hit debuff stored in a list. A debuff is made out of 3 variables, 1 for setting the type of the debuff, and 2 for controlling the strength and the duration. Anytime damage is dealt to an enemy, the apply debuff function gets called, which calls the effect tick coroutine, which acts differently based on the debuff. This coroutine loops until the internal variable t becomes 0, which represents the remaining duration of the effect. Some effects wait until the end of the duration and set t to 0, while others like the poison debuff tick every half a second dealing damage to the enemy and keep calling the effect tick coroutine until t becomes 0. Enemies have 6 patterns in which they can move in. This includes moving randomly, towards and around the dice, moving horizontally or vertically, or just not moving at all. There are two variables which control the speed and time between changing directions. The way the enemy moves is with applying forces to a rigid body. Each movement pattern calculates the direction the enemy will move in. From all of those, the most interesting one is the pattern where the enemy rotates around the dice. This pattern rotates the enemy to face the middle of the screen and applies force sideways and towards the main dice. This makes the enemy go around the middle and used by the circle enemies. The small diamonds only move vertically, while the big square only moves horizontally. Small squares don't move at all unless they are pushed, and the mega diamond moves completely randomly. All enemies shoot projectiles after 1.5 seconds had elapsed after spawning. Most enemies have laser projectiles. The small diamond shoots 5 physics-based projectiles that collide with each other, and the mega diamond spawns a bunch of small triangles. When enemies die, they give the player a single coin. You can spend these coins in the shop for new dice and upgrades for the main dice. At the end of every round, the shop gets refreshed. The top row only chooses dice that you haven't bought yet, and the bottom row chooses upgrades for the main dice. The game detects which item you click in the shop using the I-pointer click handler interface, which allows the script to receive on-pointer click callbacks. When that method gets called, the game checks if you have enough coins and if you haven't already bought that item in that slot. If so, the item you are buying gets removed from the available items, except if it's an upgrade, and gets added to your dice inventory. I haven't actually talked about main dice upgrades yet. The way those upgrades are handled are quite interesting. When you buy an upgrade from the shop, that upgrade gets added to a list and the method gets called to refresh the stats of the main dice. The script loops through every bought upgrade and counts how many of them have been bought from each type. Every max life upgrade increases the main dice's max health by 15. Regeneration ticks every 3 seconds and the amount of life you gain is limited to 3 due to balancing. Shockwave and icicles start spawning after a single upgrade every 10 seconds. Every upgrade decreases the time between shots by a second, with the minimum time being half a second. Once you press enter, you start the next round. The current wave's enemy types are separated into their own coroutines. The coroutine needs a couple of variables such as the amount and the rate of the enemy spawning and the enemy prefab. After 2 seconds, a for loop generates a position valid for the enemy and spawns one there. Then the script waits for a given time and repeats until all enemies of that type are spawned. A boolean list keeps track of when the spawner coroutines finish, and when all of them finish spawning, another coroutine gets called, which waits until every single enemy dies. Anyways, this was an interesting video to make. If you liked it, then click the like button and even subscribe if you feel extra spicy. But thanks for watching and see ya!